Cool. So thank you all for joining. My name is Amy Pellegrini. I'm from the Thoughtworks Barcelona office. And the topic of the talk today is going to be reverse goal setting with MCP, which is the MCP protocol, model context protocol, more precisely, created by Anthropic. And the idea is to explore, potential use cases for this new technology and see how can we find a valid use case and maybe do some a little experimentation, understand how it works, and play around with a proof of concept. So the talk is going to be divided in two parts. I'm going to make my presentation, try to share my brainstorming about how to start using it and how to find a valid use case, and then we're going to look into some code, and it's going to be interactive and we can see it actually running. So cool. So the first question is, what is MCP, right? This is the what part of the talk where we try to address the question, right? So if we zoom in a little bit on the MCP protocol, so this protocol is designed by Anthropic, which is the company behind Claude. Most of you will be familiar with Claude. It's the famous LLM chat app similar to ChatGPT that you can, put questions, it will generate some answer. And from their documentation, what it says is that the model context protocol is an open protocol that enables seamless integration between LLM applications and external data sources and tools. MCP provides a standardized way to connect LLMs with the context they need. And the crucial keyword here, I think, is the word context. So if you think about LLM, which is this small component right here on the bottom of the diagram, so the LLM can only, generate content based on its original training data, which may be very, very vast, but it will not have much context on your particular situation or your particular, domain of interest, which means that it's going to be limited in the sense of, if you want to know something very specific about your particular situation, it will not be able to help you. So the MCP protocol, what it enables is the LLM to connect to external data sources and expand this context with the use of tools. And you can configure it in different ways. So using the tool is one way of expanding that context. But the other important enabling feature of this MCP server protocol is that also allows the LLM to perform agentic actions and manipulate those external data sources. So you could, for example, you could write to a database, or you could create a file in your file system, or you could fetch your emails and potentially even reply to your email. So you can expand the capabilities of the LLM and also find ways to expand that context. So when you chat to it, the responses that will give will relevant to your particular situation, to the context that you're providing. So one important distinction I want to make is that we should not confuse the MCP server with the tools. So the tools are very basic implementations, very simple lines of code that will perform specific actions. It could be read to a database, write to a database, call some API, manipulate some file in your file system, very small, atomized things, which are intended to be stateless. So you do something, you finish, there is nothing persisted once you complete that action. But the MCP server is a much broader component. It could be deployed on the cloud somewhere. It could integrate with multiple different tools, and it will persist state. So whatever context you are adding via the MCP or whatever information or tools you're integrated, it could be persisted across a whole session, and it could handle things like authentication, authorization, and different levels of orchestration between the LLM and the tooling that you're providing. And for now, I'm going to focus only on the server part of the model context protocol, because otherwise we will not have time today to dig into this. So I'm just trying to keep it very focused. So, okay, so now we discussed the MCP protocol. We discussed, how integrate with the LLMs. The question is, So what, are we doing just for the sake of the hype? Are we just trying to jump on the bandwagon without any clear idea of why are we doing this? So I'm trying to ask the question here, how can we find a valid use case for this technology? And this is the why part, right? So let's think about this a little bit. So why building an MCP server? If you think about all the applications that you have in your mobile device, that you have in your laptop, I can think of multiple different things, but I generally, if I think about user-centered applications, I like to distinguish as two different kinds. One would be data oriented applications, things that allow you to manipulate or to see data in different ways. Like, for example, a spreadsheet app or a banking app or something that will let you do some analytics or trying to understand, what's happened with a lot of data that you have. And then there are general purpose apps like, I don't know, YouTube, where you can watch videos, or a game that you play in your mobile device, or calculator apps. They are very specific tools that will let you achieve a very specific outcome. And they are usually very deterministic as well. You have very concrete expectations about what will happen. So in order to come up with a valid use case, we should have to think about something that is not accounted already in these kind of apps, that it would, benefit from the features of an LLM, and it will also provide something that the LLM by itself cannot do. And this brings us to the characteristics of the LLMs, right? The LLMs provide output that is non-deterministic. It could change every time you ask a question. And also, they have a limitation that they will tend to forget things, so they will tend to, lose track of what's happening if the context becomes too broad. So one thing we could do is try to persist that context in a way that is meaningful. And thinking about the apps themselves, I was thinking, what if I can create something that address the need of a goal, right? Because if you think of an app, it's something designed to achieve some task or achieve some goal. But what if we can abstract that a little bit more and think about goals in general, right? So I start thinking about, okay, how can we devise something that will help me with goal setting and goal tracking and helping me achieve my goals? And it should be something better than a to-do app, because a traditional to-do app is very limited in the sense that, it's very atomized, very specific. You need to precisely very define all the tasks that you want to do, keep track of them. It's very manual. So I want something more broad, something that will help me brainstorm, maybe when I don't know really exactly what I want to do. And the other thing is that sometimes goals can be very abstract. Sometimes you don't know what you want to do, really, right? It's like, I want to earn money. Okay, so why you want to earn money? I want to earn money because I want to, have, be safe, feel safe in my life. So what you want is safety, really, or stability. And then you want stability. Why? Yeah, I want stability because I want to enjoy my life, and I want to spend time with the people I love in a way that is non-stressful. So it's like those things don't have a very precise way of defining how do you achieve them. So I think in this scenario, using an LLM could be helpful, because given that the output is non-deterministic, it fits well with this sort of creative thinking. So, okay, so the question is, how can we address any goal? And if you think about a goal, it's usually something in the future, something that you need to achieve somehow, you need to perform some series of tasks, right? And it brings us to the question of the passage of time and the actions that you need to take to achieve that goal. So if you think of the task, right, is something more specific. And if you want to, let's say I want to buy a house, you would have to start thinking about, okay, what task do I need to do so I can buy a house? Well, I will have to collect the money, which means I will have to find a job and probably set up some saving plan and investigate with the bank what are my financing options and so on. So there is a whole series of steps I need to take in order for me to eventually complete that goal. And that will, go in a straight line as time progresses. So time is not going backwards. So it's always going to be some time in the future. And if you start, orchestrating these tasks a little bit more in detail, then you find that some things need to happen in a specific order. Like you cannot buy a house if you don't have the money, and you cannot decide which house you want to buy if you don't know what your budgeting option is. So you need to kind of come up with a structure for, what I'm going to start doing first and what can be parallelized, what things can happen at the same time, right? As I'm doing research and then I'm saving money, and then at the same time I'm planning how my house is going to be. And as time progresses, these tasks will lead to other tasks that may be for the time being blocked, until you can eventually achieve the goal. So yeah, and probably the nerds in this audience will start looking at this graph and thinking, okay, but this looks very familiar. And if you have done some computer science or some graph theory, you will probably recognize this pattern here. And it looks very familiar, and because it is precisely a graph, right? So the question is this an acyclic directed graph, which is a very specific type of data structure where it goes in a particular direction. So if you see the arrows follow the passage of time. The nodes are connected always in a specific direction, which is in this case the future. And there are no cycles. And so the reason why there is no cycle is because you cannot go backwards in time, right? So the actions are very specific and atomic, so it should help to achieve them. So yeah, it is exactly that. It's an acyclic directed graph. So, okay, so now we come to the section where we try to build this. And the advantage that we have is, like, if I go back a little bit, is that, once you have a data structure like this, you have a lot of algorithms to manipulate it. In computer science, we have a whole host of, tools and algorithms to manipulate graphs and do very interesting and cool things. So, okay. So now I'm going to jump to the actual code. And what I have here is my own implementation of an MCP server. I'm gonna hide this for a while. Oh well, it's not working very well. So I have a repository here, and this will be linked in the slides that we share. And this repository is sort of a monorepo. So you have different folders here with different components, and one of them is the server. And this is the MCP server part, which we will be focusing today. So in the server, what you have is a server configuration that is coming from here. So basically, this is the MCP server component. And at some point here, it will be configured, and it will be assigned a series of utility functions or tools. So for example, if you think about the goals that we just mentioned, we have a function to create a goal. We have a function to create a task, which is like a smaller kind of thing you need to do to achieve the goal. We have functions to get those tasks by a given goal ID, get all goals, update, and so on. So all these utility functions are what I was mentioning, right? These things that will help you manipulate this graph. And in here is the server configuration where you can actually, define it and pass the resources and tools. Resources would be, it could be files, or it could be sources of context data. But yeah, this is a bit out of scope for now. So in here, you can assign the tools. So for example, once you instantiate your server, you can set up a tool, and you have an interface that the LLM will use to understand how to use your tool. So in here, you can describe, what is the purpose of a specific tool. In this case, is create goal, and it will create a new Lifetree goal. And by the way, I call this MCP server, I call it Lifetree, because I was thinking, how can I name it in a way that is, interesting and it makes sense. And when I saw that data structure thing, that graph, I was thinking it looks like a tree, right? It's like we use the concept of tree to refer to graphs. And I find it like a nice, analogy of life, or could say like a metaphor, right? You have this tree that is growing, that represents yourself, growing to your goals. So I find it very poetic. So I thought it was going to be a good idea to call it Lifetree. So yeah, if you see here, I can assign more tools. So there is one for getting all the goals, another one for getting the task. And you have here SOT for the defining the interface and the validation of the inputs. This is very important for, helping your LLM communicate effectively with the tools. And yeah, and you have a whole bunch of tools here. And all of this is running in Firebase. So I have a Firebase instance running locally here. And I use Firebase because I find it very easily to spin up a database service that I can use very quickly. So if you see other parts here, okay, in the server, there's the Firebase integration here. And I have my Firebase configuration where I define the different services. And in the web folder, I'm working on client. So the client would be the actual chatbot applications where you integrate the LLM with your server. But this is still work in progress, so I'm not going to discuss it today. And by the way, if you look at this code in GitHub, you will notice it's quite sloppy. And this is because it's a very experimental proof of concept, still working on it. So I expect it to progress over time. It's not a finished thing at the moment. Cool. So now let's go to a demonstration. So once you have your server and you know where to locate it, you can use the configuration for Claude desktop app to, to tell Claude where is this server located. So if I go to Claude, I have my Lifetree project here, and it's already, registering the server here. So you can see you have a bunch of actions that you can do. And if I tell Claude, let's say, okay, I want to see my goals, it will retrieve them from the database that I have here. So it can list, a whole of goals. I have, experimented a little bit here. So, and you can see them actually if you go to the actual Firebase instance. You can explore it here in the emulator suite. So I have my Firebase instance running here. I can go to the Firestore emulator, which is the database, and I can see all the goals that have been created and all the tasks that have been created for those goals. So now what I can do is say, okay, I want to create a new goal, right? Let's say I want to give more public presentations, right? And it will start thinking and it will create the goal for me. And it will suggest a few tasks, right? So how can you start giving more public presentations? So you need to identify speaking opportunities, develop presentation topics. I would like to find more opportunities. Can you suggest some tasks to achieve this? So it will brainstorm with us what we can do, And now it's going to ask me, would you like to save this task? And I'm going to say yes. So it's going to start creating all these tasks. And as you can see there, it's taking its time. And while it's doing this, you can actually come here and see the thing growing, right? It's already writing in my local database. Yeah, and it's taking its time. So you need to be patient with it. So before this is taking too long, yeah, okay. Now I need to organize in a logical sequence. So it's kind of defining the sequence of the tasks. And now it's going to organize them. Yeah, it's organizing them in a particular sequence. And it's asking me, do you like to see it as a diagram? And I say yes. Okay, so it's going to create a diagram. And you can see here it's using this syntax. And yeah, you can see it here. It's kind of like mapping the goal and then the different tasks you need to do and defining a sequence, right, of what needs to happen in what order. And in here, you can see even it's kind of maintaining the states of the task. So this one is saying not started and so on. And here I can tell it, right? Actually, the develop 3.5 signature task is completed. And if I tell this, it's gonna update it. Update my diagram. And now it's showing like it is completed. So yeah, I find this exercise very interesting because it's my first exploration on MCP. And yeah, I hope that you know yourself, you can find similar applications. And yeah, that's the gist of this call. So if that's okay with you, we can proceed to some questions if you have any. Let me see if there are Q&A here. No open questions. Okay, nice. Cool. So we are 5 minutes ahead of schedule. I would like to ask Barbara if you have, okay, so I see there is actually a question.
Yes,
Yeah, Dave Rose.
Yes, thank you. My question is, and I don't obviously, I've used the LLMs, but if I have an application that has like an organizational tree with many thousands of branches, and separately, I provide the LLM with access to the tree, and then also access to, let's say, different classes that users that are assigned to branches have attended. And I asked the LLM to figure out, let's say, who is the closest person to a physical location, let's say a branch in New York City, that has these skills and abilities based on their history of classes that they've taken. Will the LLM reliably figure that out, or do we just have to write queries to take care of that? And what I'm trying to understand is how the LLM can reason, provided external data sources, if they're not truly linked together.
Okay, so that's a very interesting question. And I guess it depends on how you will, you know, expand the context, right? So the context is what we were talking before, right? As long as the LLM can, you know, collect all those data sources and put it into a context that it has access to, and there are different ways of doing that. So this is one way. There are, for example, there is RAG augmentation that you can do to increase the context, so you can provide resources. As long as you can provide that additional context to the LLM will be able to reason across all that context. So what you have in this case is two different, you know, data sources that may not be linked on their own, but if you make the connections and you allow the LLM to access them and to increase its own context, then it will be able to find the relations there. And the other question is, how can I validate if this will work? So I don't have an easy answer to that, because you will have to basically find some benchmark or some way of verifying, you know, that the outcome is actually what you expect. So in that case, you would have to devise some kind of test that you want to do to ensure that, you know, when it's actually doing this connection, it's doing it effectively. But also, I think the very important question I want to raise here is like, is that going to be more efficient than doing it yourself? Look, because going back to the question of finding a valid use case, right? We would have to assess how are you doing it now, and how, you know, how do you measure your productivity in that sense to understand if bringing this sort of experiment would increase it or improve it in some way. So you need a lot of already, you know, metrics to understand that. But yeah, I would say, you know, start thinking about what is your expectation, and or what is your current understanding of how you do that, and see if that can be optimized in a meaningful way. And my answer from a technical perspective, I would expect an LLM should be able to get context from different places and make meaningful correlations. So yeah, I would expect to find some useful thing there. And there is more questions.
Thank you.
Awesome, thank you. An idea is you could provide in the LLM context an example of a connection between the data sources. Oh, okay, yes, this is what we are discussing. And what if the LLM was asking me what is the reason why I set myself a goal? Well, this one is very interesting because, you know, I did an exercise myself, which I call it reverse vibe coding. Because, you know, the vibe coding movement is around you telling the LLM or the agent in this case, what you want it to do. But something I did, and by the way, this is how I build this proof of concept. I told the LLM, can you help me build this thing I want to build? What stack would you choose? You know, and start telling me, giving me ideas. And then I asked him, okay, I never implemented this Firebase configuration. Guide me step by step. How should I do it? And it was the LLM telling me step by step, how should I do it? And I find it very interesting because it was the exact opposite of what you would think, right? The interaction is not me telling the LLM, it's the LLM telling me what I should do. And I think this goes to a similar point, right? Maybe, you know, you can train your LLM to ask you questions. And it's a very interesting point. I actually have a Socratic tutor thing here. Oh, it's not here. Okay. So I have a Socratic tutor. How can I say? There is a ChatGPT that lets you do like customized GPTs where you train the LLM to ask you questions for learning. So if I say, for example, I want to learn these topics, I want to learn Python, and the LLM start asking you, okay, what do you know about Python? You know, do you know what how classes are instantiated in Python and so on? So yeah, I find that very useful. Cool. So we are on time. So I guess that's it for my part of the talk. Thank you all for your contributions, and I hope you find it useful. And I'm gonna hand over to Barbara so we can proceed.